Hello everyone. I'll screen share real quick. Can you see the PowerPoint, or is it like the editing? Hello?
It's fine.
All right. I'll start. All right. Hi, I'm Jonathan Zhang, and I'll be addressing the question, how do the actual risks and benefits of nuclear energy compare with other existing energy technologies and those that will be a part of the world's net zero future? Before we get into answering that, let's first set the stage. The context that surrounds this question is obviously climate change. We all know it, we all hate it, and yet nobody wants to fix it. Why? One big word: sacrifices. It doesn't matter that climate change is destroying the world. If solving it means my energy bill goes up by $20, then the world can burn for all I care. And when everyone has that mindset, trying to transition from fossil fuels to clean energy is impossible. So where does nuclear fall into this situation? Well, what nuclear can do is that it can lessen the sacrifices we need to make. Just like how going down a 20-foot slide is preferable to going down a 20-foot drop, nuclear makes the transition to a net zero future less painful by acting as an in-between, replacing fossil fuels and giving renewable energy sources more time to further develop, gradually transitioning us into a carbon net zero world. So how's this transition from fossil fuels to clean energy going so far? Well, as you can see, clearly not well at all. Fossil fuels still dominate our modern energy distribution. And although clean energy is at least a significant minority, we're still losing by a lot. So let's look into the distribution a bit deeper. What specific energy sources does our power supply come from? Well, on the fossil fuel side, petroleum, otherwise known as oil, produces about 31.4% of world energy. Coal in second place comes in at 27.4% of world energy, and natural gas at third place contributes 24.9%. Notice how each different fossil fuel type produces more energy separately than all clean energy combined. That's pretty unfortunate. Now, on the clean energy side, hydro and nuclear produce the bulk of clean energy. Hydro produces about 6.6% of the world's energy, and nuclear produces about 4.1%. This is followed by wind energy at 2.4%, solar energy at 1.3%, biofuels at 0.6%, and everything else at 0.4%. So there we have it. That's every major competitor to nuclear energy. Additionally, we'll take ocean and geothermal energy out of the generalized other category. They may not produce much of the world's energy, but they have some noticeable features that we can discuss. So we want to know, how does nuclear energy compare with all these other sources? Before we discuss any other energy sources, let's first discuss the benefits and risks of nuclear energy. One of the big pros of nuclear is that it's essentially carbon-free. It's not technically currently possible for any energy source to be completely carbon-free, especially if you count construction emissions. However, according to the Intergovernmental Panel on Climate Change, nuclear energy is the least carbon-emitting energy source, beating even wind and solar energy. Additionally, nuclear fuel, uranium, is extremely energy efficient. A handful of uranium pellets will equal truckloads of fossil fuels worth of energy. Additionally, nuclear reactors have a comparatively low operational cost compared with other energy power plants, even when factoring in waste disposal and other costs. Finally, the biggest benefit of nuclear, the one that gives it an advantage over many other clean energy sources, is that it's reliable. Just like a fossil fuel plant, a nuclear reactor can run anytime, anywhere, as long as there's enough fuel. But nuclear has its fair share of risks too. For example, uranium is not a renewable resource. There's only so much uranium on Earth, and once it's gone, it's gone. Additionally, despite the low operational costs, the construction costs of a nuclear power plant are sky high, reaching several billions of dollars and sometimes into the tens of billions. Not to mention, there's also significant time costs, with it taking multiple years for a nuclear power plant in construction to reach operation. Additionally, before it can be used, uranium needs to be mined out of the ground to be used before it can be used as fuel. Mining anything is an extremely destructive process. And from mine waste runoff to exploitative labor practices, mining has a massive human and environmental cost. Finally, it's time to address the elephant in the room: nuclear waste, nuclear accidents, and terrorism. We all know that nuclear power plants produce dangerous radioactive waste that is extremely hard to destroy, And this is nuclear energy's biggest weakness. This waste is costly to store safely and oftentimes needs to be stored for very long periods of time. Additionally, as demonstrated by Fukushima and Chernobyl, sometimes accidents can happen in nuclear power plants, which can lead to massive long-term consequences. And with such consequences at stake, it's no wonder that many people worry that nuclear power plants could be terrorist targets in order to cause mass destructions. These three risks are often the public's biggest reasons for opposing and stigmatizing nuclear energy, but as we'll see shortly, these risks are often overstated. So now that we understand nuclear energy, let's compare it to the biggest modern day competitors, starting with the big three fossil fuels: petroleum, coal, and natural gas. Sure, there are some differences between the three, especially with natural gas being a bit safer and more clean, but their specific consequences and benefits aren't particularly unique to each other. So they can be generalized into one category: fossil fuels. And on the benefit side, fossil fuels are great because, relatively speaking, they're easy to find in the ground, they're easy to transport to power plants, the power plants themselves are comparatively cheap to build, and fossil fuel use can produce useful byproducts such as plastic. In other words, fossil fuels are extremely convenient. Additionally, they're quite energy efficient as well. Although they don't really compare to nuclear, the amount of energy stored in a set amount of fossil fuels is still significant. Furthermore, the operational costs of fossil fuel power plants are also quite low. Additionally, they're also a reliable fuel source. As stated before, they can run anytime, anywhere, as long as there's fuel. However, on the risk side, fossil fuels are a non-renewable resource and they're in limited supply. They also need to be mined out of the ground before they can be used. And of course, there's also plenty of pollution with any type of fossil fuel. They release greenhouse gases during production, they cause oil spills and acid rain, all of which can severely damage the surrounding environment and lead to multiple consequences in the land, air, and water. There are also plenty of health risks with fossil fuels. Workers in fossil fuel plants can expect lower lifespans, and air pollution can cause widespread lung issues in the general population. So looking at this table, we see that there are a lot of similarities between nuclear and fossil fuels. In fact, their risks and benefits are nearly identical, except instead of greenhouse gas pollution for the fossil fuel side, we get radioactive nuclear waste. When we put it that way, it's no wonder people are reluctant to switch to nuclear. But let's look into it a bit deeper. Fundamentally speaking, people are scared of nuclear waste, nuclear accidents, and terrorism because they can kill people. So let's see just how many people nuclear energy has actually killed. For every 1,000 terawatt hours of energy generated by a nuclear power plant, which is about enough to power 27 million Europeans for 1 year, an average of 70 people will die. This factors in both Chernobyl and Fukushima. This seems like a lot, but let's compare it to fossil fuels, which for the same amount of energy will kill about 15,789 people. This includes deaths caused by air pollution, but it does not factor in shortened lifespans and decreased quality of life. This number is a proportional average of all three fossil fuel types, and because of natural gas, that average is heavily less skewed. However, coal and petroleum have even higher deaths for the same amount of energy. As you can see, nuclear power isn't as dangerous as people think. And compared to what we use today, a lot of fossil fuels, it's pretty safe. Because of this, when compared to fossil fuels, both the likelihood and the consequences of a nuclear accident are relatively small, making it less of a concern in this specific comparison. Additionally, since nuclear is more energy efficient and cheaper to operate, fossil fuels lose those benefits in this specific comparison. Further, although both fossil fuels and nuclear energy have limited fuel supplies, the limited fuel supply of nuclear fuel is significantly larger in terms of energy than fossil fuels, as there's enough uranium in the ground to last us for 80 or more years to come, not to mention other sources. Next, because of uranium's high energy concentration, there's less mining required to produce the same amount of energy than with fossil fuels. Additionally, by spending a relatively small amount of money on security, the risk of terrorism is almost completely negated. Finally, a rarely mentioned but crucial advantage of nuclear is that there is still much room for improvement and innovation in the industry. New technologies like thorium reactors, small modular reactors, and breeder reactors are set to revolutionize the nuclear industry, reducing some of its biggest drawbacks. Meanwhile, fossil fuel energy has been in use for centuries, and compared to renewable energy, its innovation has somewhat peaked. There isn't much further left to improve, and yet there are still so many problems with fossil fuels. Looking at this new comparison, nuclear energy is the clear winner, and there shouldn't be any competition whatsoever. However, saying that nuclear energy is better than fossil fuels is low-hanging fruit. It's like saying the iPhone 13 is better than a telegraph. Of course it is. That's not really groundbreaking news when one of the options are 100 years old. So, how does nuclear compare against other clean energy sources? Well, let's start with its biggest clean energy competitor, hydropower. First of all, a big part of hydropower are dams, and dams are able to prevent floods if a river regularly overflows. Additionally, dams are low carbon. However, unlike nuclear, the released carbon from a dam is not negligible. Though it is still significantly better than fossil fuels, dams can cause the release of significant amounts of greenhouse gases when they change the shape of rivers. Organic matter in areas now newly underwater or newly on dry land will decompose, and they release the carbon dioxide inside them. But moving on, dams also have very low operational costs, just like nuclear. Hydropower is also a renewable energy source, and since water flows regardless of time of day, hydropower is a very reliable energy source as well. On the other hand, hydropower has its fair share of risks as well. Just like nuclear, hydropower has some high construction costs. Unlike nuclear, however, dams are location limited, and they can only be built on a river. Surprisingly, just like nuclear power, dams could also be the target of terrorism. Dam failures can be extremely destructive, and if not handled properly, can result in the deaths of hundreds of people and billions of dollars in damage. Finally, and one of the most important factors, is that dams have a staggering environmental and human impact. The construction of a dam can block the movement of wildlife and can cause the river it's on to literally change shape. For example, this is how the construction of the Three Gorges Dam in China changed the shape of its river over the course of 4 years. This movement of water can cause mass displacement of people, destroy infrastructure, and have consequences far downstream, which is demonstrated by a separate dam in India that caused Jog Falls, a waterfall far downstream, to almost completely disappear after the dam was finished being constructed. These two events are unrelated. However, this human impact issue ultimately stems from the fact that dams have to be built on a river. Building a nuclear reactor very close to a population center could also result in similar consequences. However, nuclear power plants can and are built far away from people. On the other hand, dams must be built on rivers, and cities are often built around rivers, making some consequences inevitable. Moving on, the next two biggest energy sources are wind and solar. These two energy sources are actually quite similar, and as such, they will be evaluated as one. Wind and solar energy are both essentially carbon-free. Though nuclear does technically emit slightly less carbon, at this level compared to fossil fuels, the differences are negligible. Wind and solar are also renewable energy resources, and since all the wind turbines and solar panels do is sit there, the operational costs of these two energy sources are tiny, only requiring some occasional maintenance. Additionally, solar and wind are both very new technologies, and just like nuclear, have plenty of room left to improve and innovate. These energy sources are also less disruptive than nuclear. Solar panels can be built literally anywhere, and both solar panels and wind turbines will be less damaging to the surrounding ecosystem than a newly built nuclear power plant. For risks, wind and solar are just like nuclear. They're expensive to construct, but they also require lots of rare earth metals, the mining of which is extremely destructive. They are also location limited, and although they aren't as location limited as dams, since wind and solar farms need to be built in areas of high wind and sunshine, and places like that aren't very hard to find, it still limits where these technologies can be built. Finally, the Achilles heel of wind and solar is their unreliability. We can't control when the wind will blow, and solar panels don't work at night when we need energy the most. Instead, costly power storage systems are often needed, which will reduce efficiency and make solar and wind economically infeasible for many places. This means that a different energy source, such as nuclear, is often required to fill in the gaps. Although solar and wind will likely be the primary energy sources in the far future, as of today, nuclear is needed to make up for their shortcomings as more research helps to improve their efficiency and reliability. After wind and solar come biofuels, or in other words, burning things, whether it be straight trees or processed fuel like ethanol. Biofuels have the advantage of being a renewable energy resource, and like many clean energy sources already, they have very low operational costs. Biofuels are also reliable, and they can produce energy regardless of time and location. Additionally, a unique advantage of biofuel power plants is that they are somewhat able to recycle our trash because they use fuel that can be made from organic waste products. Additionally, as a novel fuel source, there's still room for innovation. However, when it comes to risks, biofuels have many. The worst of all is that biofuels aren't low carbon at all. Carbon emissions can vary greatly depending on the fuel source, but they generally range from around 78 tons to 230 tons of carbon dioxide per gigawatt hour. Obviously, that's expected when you're burning things. Those emissions are about 2 to 7 times as much emissions as hydro energy and about 16 to 77 times as much as nuclear. Still, it is significantly better than all fossil fuel types. Biofuels also can require significant amounts of land and water to grow the necessary raw materials to make the fuel they need, which comes with all the environmental detriments of farming. On top of that, the fuel that is produced for biofuels are low energy density and compared to fossil fuels. Keep in mind, though, that new advancements in the biofuel industry, such as cellulosic ethanol, could make biofuels cleaner and more energy dense in the future. However, as for now, nuclear still stands as the better option. After biofuel comes geothermal energy, which is the use of the Earth's internal heat to generate energy. Geothermal follows much of the trends of many clean energy technologies. It's low carbon, it's a renewable resource, it has low operational costs, and the energy is continuous, as the Earth will always be producing heat, which also makes geothermal energy a reliable energy source. There's also continued innovation in the field to improve the technology as well. However, just like the other just like the other clean energies, the initial cost to build a geothermal power plant is very high. And finally, what holds geothermal back is its extreme location limitations. Power plants can only be built in places where geothermal heat is readily accessible, such as geothermal vents, which can eliminate entire small countries from the energy source and prevent large-scale growth. Afterwards, it comes ocean energy, which is very similar to hydro energy, but rather than using river currents to generate energy, it harvests the energy of the ocean, whether it be in tides, salinity gradients, or heat gradients, to make electricity. The benefits of oceanic energy are very similar to hydro, with it being essentially carbon-free, a renewable and continuous energy resource, making it very reliable, and there's continued innovation in the field as well. However, just like hydro energy, ocean energy can be a disruption to wildlife, especially because they're typically used in shallow coasts where wildlife is most concentrated. Obviously, it's also very location limited, as it must be built along a coast. Finally, although ocean energy generators do exist and are used on a small scale, they're not yet commercially available and likewise need more research to be viable. I know that I previously said that having more room to improve is seen as a positive, but the issue with oceanic energy is that it's just too far behind. Other green energy sources can also improve further, but the difference is that they're still competitive energy sources today. Since oceanic energy isn't even very commercially available, much more research and development is necessary before it can be used widely, meaning that today, other energy sources, like nuclear, need to be used until oceanic energy can be fully developed. Finally, there are many other small energy solutions that make up a small part of total energy production. For example, in Worcestershire, excess heat from a crematorium is being used to heat pools. Oftentimes, these small-scale energy solutions can be the most efficient and cleanest option in the local area. However, that's also their greatest weakness. Because many of the fuel sources in the other category are only local solutions, they're unsuitable for widespread use. So now we've gone over every major competitor to nuclear energy. This now begs the question, which one is the best? Obviously, everyone here is going to say nuclear is the best. In the current day, it's the best option because of its cleanliness and consistency. Nuclear takes the efficiency and convenience of fossil fuels and combines it with the environmental friendliness of clean energy. Nuclear power can be generated anytime and anywhere, all without polluting the environment. It's the best of both worlds. Sure, nuclear waste is a major issue, but it can be concentrated and isolated from populations, unlike the greenhouse gases from fossil fuels. And on top of that, new technologies are being researched and developed today that may eliminate or reduce the issue of nuclear waste altogether. However, despite all that, I don't believe that nuclear energy alone is going to be the solution to climate change or the current day energy crisis. And the question of which clean energy is best is a fundamentally counterproductive question. Let me explain. You might have noticed a common trend among the benefits and risks of all the different clean energy sources. Compared to fossil fuels, clean energy as a whole pollutes less, has lower maintenance costs, makes it easier to produce energy, and they're continually innovating. However, many clean energy sources are limited by their location, carry high initial construction costs and are less reliable than fossil fuels. The important thing about this, though, is that there are exceptions to this trend. Notably, nuclear energy is not location limited and is just as reliable as fossil fuels. This means that when we use nuclear energy in conjunction with other clean energies, we can make up for their inability to produce energy in certain areas or times. This allows us to transition away from fossil fuels while still giving the clean energy sector as a whole more time to further innovate and develop, leading to lower initial costs and more competitiveness against fossil fuels in the future. We must remember that in the energy industry, each individual clean energy source is completely dwarfed by any of the three main fossil fuel types. When we spend time debating whether or not to use a specific source, such as stigmatizing nuclear energy, all we're doing is wasting time and making it easier for fossil fuels to maintain their grip on our modern energy industry. Only by working together will clean energy be able to practically, economically, and environmentally be superior to fossil fuels. And only through that will we be able to take this modern day energy breakdown and change it, making this possibly the energy breakdown of tomorrow. And only then should we start arguing among each other. Thank you. You're muted. I can't hear you.
Oh, I didn't quite click hard enough. Thank you. Thank you for that presentation. That was great. So now we will go ahead and let the judges ask any questions that they might have for the next few minutes.
Hi, Jonathan. This is Elizabeth. Thanks so much for the presentation. It was really excellent. I have a question. I'm sure that in your research you found that some of the current growth of renewable energy like wind and solar is due to policies that help make it more attractive. If you were to propose a policy to make nuclear energy more attractive, what would it be?
So it probably follows a lot of the same trends as we're seeing with the policies like the other energy sources, like reducing taxes on it and mainly just incentivizing people to switch to nuclear over not only fossil fuels but other renewable energy sources by just what's the word? I forgot the exact word, but it's when the government like subsidizes. Yeah, it's like by subsidizing the nuclear industry and promoting it.
Okay, thank you.
Jonathan, this is Katie Lennox, the invisible person for today. You started off with the premise that nuclear energy is clean. There are many people around the world who want to debate that point. What do you say to that idea?
So the thing that I like about nuclear is that although it does produce like the nuclear waste that can be harmful to the environment, it's easier to keep the nuclear waste in one space. We can't just gather all the carbon dioxide in the atmosphere and put it underground, but we can do that with nuclear energy. And although it is expensive and hard to do as of now, it's still a possibility and we can make it cheaper in the future. But we're just never going to be able to filter all the carbon dioxide or greenhouse gases from the air that are caused by fossil fuels.
I like that argument. I haven't really heard it put that way before. That was very interesting. And then two-part question, which is related. You didn't really talk about reprocessing or recycling. Have you looked into that at all?
So there are, like, as I said, there's new nuclear reactors that are looking, especially breeder reactors, which are seeking to like increase, because already nuclear energy sort of recycles, like I think it was around like 90 or so percent of the, obviously you know more than this on this fact, but like I read that it recycles about 90% of the nuclear waste already to produce more nuclear waste. And I mean, I don't know the exacts of the new technologies, but I do know that new ones are being researched right now. And I heard that like many of them are ready to implement. However, they just lack the funding to do so.
Yeah, just for your information, it's kind of the US, we're the ones who don't. We don't reprocess now. The numbers you're seeing about recovery of some of the material are actually everywhere but here. So it's another thing for healthy debate, but no, I appreciated seeing your talk. Thank you very much.
So Nathan, I thought it was a very well put together presentation, very well rehearsed. Really appreciate the way that you put together the information and the comparison. You did say something early on though that I want to ask you about. You mentioned nuclear as a bridge technology, and that implies that you feel that it's not part of the long-term solution, only part of the intermediate solution. Do you care to comment on that?
So the long-term would be very far in the future because like renewable energy, especially things like solar and wind, like they're just like they're so inconsistent with how they produce energy that nuclear energy is going to have to, you know, stay around. And right now, nuclear energy is often coupled with solar energy, with in order to produce energy when the solar panels or the wind turbines can't produce energy, the nuclear power plant will produce the energy for the residents or the citizens. And so what I meant by that is basically until we can find the problem with nuclear energy is obviously the waste, and until we can find a permanent solution to just get rid of that waste completely, if we were able to make, how do I put this, it's just the waste is just a problem, and although we can store it safely, if it builds up, it's just not good. And that's why I think it's more a bridge, because it can help us, because nuclear is better than fossil fuels. And so we can use that to reduce our current emissions today, and maybe hundreds or a long time in the future, renewable energy resources, ones that don't produce any waste at all and run just off the sun, can take over. But for the foreseeable future, nuclear is the best option.
Thank you for that answer. I just want to comment, if this is an area that you continue to have interest in beyond just this competition, I'd encourage you to look at what happens with the waste from all of the different energy sources, as well as what could be the impact of continuous recycling. Right now, nuclear waste is spent fuel is only recycled once in Europe, and then it's not continuously recycled because they don't have the breeder reactors that you're mentioning. So I just encourage, if you want to look into things more deeply, to look at the waste that comes from the renewables, as well as what recycling would do with nuclear. Thank you.
Thank you.
Hey, Jonathan, this is Doug. So really nice presentation. Excellent job with the tools, the presentation tools. I really appreciate your list of references here. The way you cited references, very strong, very good practice to cite your references. I was wondering, first of all, did you happen to read anything about the difference between fission and fusion nuclear power?
So I have, and by the name suggests, fission is separating, and then fusion is combining. And fusion is fission is what we use today. We fission of the uranium and possibly other sources such as thorium, and then fusion would be possibly combining different materials into a new source. And if fusion were to become a reality, which I don't think it currently is, but if it is, then we would have almost a limitless source of nuclear fuel, which would be great.
Nice. Okay. Yeah, you're exactly right. So you also mentioned that that there is a significant amount of public concern, maybe even fear associated with nuclear power. Do you have any thoughts about how to overcome those types of public concerns?
So I do believe that a lot of the public concern around nuclear is due to ignorance. People they hear the word nuclear and they think of the bombs and they're just scared. And they think of these incidents, these one-time incidents like Chernobyl or Fukushima, and they think that it's a huge danger, and they just they aren't aware of all the other like how dangerous fossil fuels are, how many people die from fossil fuels, and just other energy sources in general. In the 1970s, or I forgot the exact date, like a dam in China, the Banqiao Dam, I believe, it failed, which caused the deaths of 25,000 people, which is more than nuclear has ever killed, including bombs. So nuclear energy, the stigma around it, I believe, is mostly due to ignorance. And because of that, the main way to solve it would be through education and through presentations like this.
Okay, excellent answer. Thank you.
All right, does anybody have any further questions for Jonathan?
No, none here.
Okay, I will take that as a no, and we will go ahead and let you hop off, Jonathan. Thank you for taking time to present to us today. And we will be in touch once we get everything all situated and put together.
Thank you so much.
All right, thank you. Have a great night.
Bye.
Bye-bye. Okay, anything you guys need to discuss amongst yourselves before we move on to the next one?
I guess the only thing that I observed was that he didn't go into quite as much detail on statistics, but I think that that was because the nature of the presentation didn't really call for it.
Okay.
I have a question for you, Angie, because I can't remember from last year. Do we give multiples of these? There's like first, second, third. I can't remember that part.
We are doing, I believe, this year we're doing it a little bit different. We have a pot of up to, is it 15,000, Rachel? Yeah, up to $15,000. And Jen's going to take a look at the scores. Our team will look at the scores that we come up with and see. We may give a first and a second. We may give 3 places where we're just kind of letting it may be one student that's head and shoulders above all the rest that just, takes the bank. So.
Okay. And I know what I did last year, maybe no one else did. I do have categories like for both these particular presentations where I'm in between points. So I give like a half in between 2 categories. Yeah, that should still be enough for you to differentiate in a score.
And that's totally fine. That's totally fine. So I do have one question for you guys that I just realized while he was presenting that I messed up on Grace Fisher's presentation. She asked to present tonight from 6:30 to 7:15. I scheduled the Zoom meeting correctly, but I scheduled the Outlook calendar invite incorrectly. So does it work for you guys to do tonight from 6:30 to 7:15 instead of tomorrow night?
Works for me.
I see yes from Doug.
I can do that. Yeah.
Okay.
Might be better in some ways.
Okay. All right, perfect. I will put it on the right day at her original request, then resend the invite. Like I said, rusty. Okay, there comes the update. So, all right. Well, our next presentation looks like it's at 4, and I totally forgot to stop recording. So all this is